The National Electrical Code, or NEC, stipulates conditions where a subpanel necessitates a main breaker. Firstly, according to NEC 408.3, when a subpanel is positioned more than 6 feet from the main panel, a main breaker is required. This regulation ensures that a readily accessible means of disconnecting power to the subpanel is available close to the subpanel itself, enhancing safety during maintenance or emergencies. Secondly, NEC 408.5 mandates a main breaker when a subpanel contains more than 42 overcurrent devices. This requirement aims to prevent the accumulation of numerous small circuits from overloading the subpanel's feeder conductors. The main breaker acts as a central point of protection, safeguarding the entire subpanel from excessive current draw. Furthermore, NEC 408.4 dictates that a subpanel must have a main breaker if it receives power from more than one feeder circuit. This situation often arises in larger installations where multiple power sources are used to supply different sections of a building. The main breaker in this case serves to isolate the subpanel from all incoming power sources simultaneously, providing a safe and reliable disconnection point. The primary function of a main breaker within a subpanel is to protect the branch circuits originating from that subpanel against overcurrent conditions. Overcurrent can occur due to various factors, including short circuits, ground faults, or excessive loads placed on the circuits. The main breaker is designed to trip or disconnect the power supply when the current exceeds its rated capacity, thereby preventing damage to the wiring, equipment, and potential fire hazards. Moreover, the main breaker provides a convenient and safe method for disconnecting power to the subpanel for maintenance, repairs, or troubleshooting. By simply switching off the main breaker, electricians or qualified personnel can de-energize the entire subpanel, minimizing the risk of electrical shock or accidental energization during work. In instances where a subpanel lacks a main breaker, the main breaker in the main panel assumes the responsibility of protecting the branch circuits within the subpanel. However, in such cases, it is crucial that the main breaker in the main panel is appropriately sized to handle the combined load of all the branch circuits in both the main panel and the subpanel. Incorrect sizing can lead to either nuisance tripping or inadequate protection against overcurrents. To elaborate further on the NEC sections mentioned, NEC 408.3, which addresses the location of overcurrent devices, specifies that overcurrent devices must be readily accessible. In the context of subpanels, this means that the main breaker should be easily reachable without requiring the use of tools or climbing over obstacles. The 6-foot rule is intended to ensure that the disconnecting means is conveniently located near the equipment it serves. NEC 408.5, concerning the number of overcurrent devices in a panel board, limits the total number of overcurrent devices to 42, excluding the main breaker. This limitation is based on practical considerations related to panel board size, wire management, and the potential for overcrowding. When a subpanel exceeds this limit, a main breaker is required to provide a single point of disconnection and overcurrent protection for the entire subpanel. NEC 408.4, which pertains to the supply of panel boards by multiple feeders, emphasizes the need for a main breaker to isolate the subpanel from all incoming power sources. This is particularly important in complex electrical systems where multiple generators, transformers, or utility feeds may be connected to the same distribution system. The main breaker ensures that the subpanel can be completely de-energized for safety purposes, regardless of the status of the upstream power sources. In addition to these specific NEC sections, other relevant sections may also apply depending on the specific installation. For example, NEC 250 addresses grounding and bonding requirements for electrical systems, including subpanels. Proper grounding and bonding are essential for minimizing the risk of electrical shock and ensuring the proper operation of overcurrent protective devices. NEC 310 provides guidelines for conductor sizing, ampacity, and installation methods. The size of the conductors feeding a subpanel must be adequate to carry the anticipated load, and the conductors must be installed in accordance with the NEC requirements to prevent overheating and insulation damage. NEC 384 contains requirements for panel boards, including their construction, installation, and marking. Panel boards must be listed and labeled by a recognized testing laboratory, and they must be installed in a location that is accessible and protected from physical damage. When determining whether a sub-panel requires a main breaker, it is essential to consider all applicable NEC requirements and to consult with a qualified electrical professional. The NEC is a complex and comprehensive document, and its interpretation and application can be challenging. A qualified electrician can assess the specific circumstances of the installation and ensure that the sub-panel is installed in accordance with all applicable codes and standards. In summary, the NEC mandates a main breaker in sub-panels under three primary conditions. Firstly, when the sub-panel is located more than 6 feet from the main panel. Secondly, when the sub-panel contains more than 42 overcurrent devices. And thirdly, when the sub-panel is supplied by more than one feeder circuit. These requirements are designed to enhance electrical safety, facilitate maintenance and troubleshooting, and prevent overcurrent conditions from damaging electrical equipment and causing fire hazards. Always refer to the latest edition of the NEC and consult with a qualified electrician to ensure compliance with all applicable codes and standards. Let's delve deeper into the rationale behind these NEC requirements. The 6-foot rule, as stipulated in NEC 408.3, is primarily concerned with accessibility and safety. Imagine a scenario where a fault occurs within a sub-panel located a considerable distance from the main panel. In such a situation, quickly disconnecting power to the sub-panel becomes crucial to prevent further damage or injury. If the main breaker is located back at the main panel, precious time may be lost in reaching it, potentially exacerbating the situation. By requiring a main breaker within 6 feet of the sub-panel, the NEC ensures that a readily accessible means of disconnection is available, allowing for a swift response to electrical emergencies. The 42 overcurrent device limit, as outlined in NEC 408.5, is rooted in practical considerations related to panel board design and wire management. A panel board is essentially a metal enclosure containing a busbar system and numerous circuit breakers or fuses. As the number of circuits increases, the panel board becomes more crowded, making it difficult to properly route and terminate wires. This can lead to a higher risk of short circuits, ground faults, and other electrical problems. Moreover, a large number of small circuits can collectively draw a significant amount of current, potentially overloading the panel board's feeder conductors. By limiting the number of overcurrent devices to 42, the NEC helps to prevent overcrowding and ensures that the panel board's capacity is not exceeded. The requirement for a main breaker when a sub-panel is supplied by multiple feeders, as specified in NEC 408.4, addresses the complexities of multi-source power systems. In large buildings or industrial facilities, it is common to have multiple power sources, such as generators, transformers, or utility feeds supplying different sections of the electrical system. When a sub-panel is connected to more than one of these power sources, it is essential to have a means of isolating the sub-panel from all incoming feeds simultaneously. A main breaker provides this functionality, allowing for safe and reliable disconnection of the sub-panel for maintenance or emergency purposes. Without a main breaker, it may be necessary to disconnect multiple upstream power sources to de-energize the sub-panel completely, which can be a time-consuming and potentially hazardous task. In addition to these specific requirements, it is important to consider the overall design and layout of the electrical system when determining whether a sub-panel needs a main breaker. Factors such as the size of the building, the type of occupancy, and the nature of the electrical load should all be taken into account. For example, in a large commercial building with numerous tenants, it may be desirable to have a main breaker in each tenant's sub-panel to allow for individual control and isolation of their electrical systems. Similarly, in a hospital or other critical care facility, it may be necessary to have multiple levels of redundancy and isolation to ensure uninterrupted power supply to essential equipment. Ultimately, the decision of whether or not to install a main breaker in a sub-panel should be based on a thorough assessment of the specific electrical system and its intended use. It is always advisable to consult with a qualified electrical engineer or contractor to ensure that the design meets all applicable codes and standards and provides a safe and reliable power distribution system. Now let's consider some practical examples to illustrate these concepts. Example 1. A residential home has a main panel located in the garage. A detached workshop is built in the backyard, approximately 50 feet from the main panel. The workshop requires a sub-panel to supply power to lighting, receptacles, and power tools. Because the sub-panel is located more than 6 feet from the main panel, a main breaker is required in the sub-panel per NEC 408.3. Example 2. A commercial office building has a main electrical room with a large panel board. A remote office area is located on a different floor and is supplied by a sub-panel. The sub-panel contains 50 circuit breakers to serve various office equipment, lighting, and receptacles. Since the sub-panel has more than 42 overcurrent devices, a main breaker is required in the sub-panel per NEC 408.5. Example 3. An industrial plant has a main switchboard that receives power from 2 separate utility feeds. A sub-panel is installed to supply power to a critical piece of equipment that must have a redundant power supply. The sub-panel is connected to both utility feeds through separate feeder circuits. Because the sub-panel is supplied by more than one feeder circuit, a main breaker is required in the sub-panel per NEC 408.4. These examples demonstrate how the NEC requirements for main breakers in sub-panels apply in different scenarios. By understanding these requirements and their underlying rationale, electricians and electrical designers can ensure that electrical systems are installed safely and in compliance with applicable codes and standards. Furthermore, it is crucial to remember that the NEC is not a static document. It is updated and revised every 3 years to reflect changes in technology, industry practices, and safety concerns. Therefore, it is essential to stay current with the latest edition of the NEC and to consult with qualified professionals to ensure compliance with the most recent requirements. In addition to the NEC, other local codes and regulations may also apply to electrical installations. These local codes may be more stringent than the NEC in some areas, so it is important to be aware of and comply with all applicable requirements. When working with electrical systems, safety should always be the top priority. The electrical shock can be fatal, so it is essential to take all necessary precautions to protect yourself and others from harm. Always energize circuits before working on them, use appropriate personal protective equipment, and follow safe work practices. If you are not qualified to perform electrical work, it is best to hire a licensed electrician to do the job. Electrical work can be dangerous, and it is not worth risking your safety to save a few dollars. Moreover, improper electrical work can lead to fire hazards, equipment damage, and other serious problems. By hiring a qualified electrician, you can ensure that the work is done correctly and safely. In conclusion, the NEC requirements for main breakers in sub-panels are designed to enhance electrical safety, facilitate maintenance and troubleshooting, and prevent overcurrent conditions from damaging electrical equipment and causing fire hazards. These requirements are based on practical considerations related to panel board design, wire management, and the complexities of multi-source power systems. By understanding these requirements and their underlying rationale, electricians and electrical designers can ensure that electrical systems are installed safely and in compliance with applicable codes and standards. Remember to always consult with a qualified electrical professional and stay current with the latest edition of the NEC to ensure compliance with all applicable requirements. And always prioritize safety when working with electrical systems. Let's continue by exploring some additional considerations related to sub-panel installations and main breakers. One important aspect is the selection of the appropriate size main breaker for a sub-panel. The main breaker must be sized to protect the feeder conductors that supply the sub-panel from overcurrent. The ampacity of the feeder conductors must be equal to or greater than the rating of the main breaker. To determine the appropriate size main breaker, it is necessary to calculate the total load that the sub-panel will be supplying. This calculation should take into account all of the connected loads, including lighting, receptacles, appliances, and equipment. The NEC provides guidelines for calculating electrical loads in Article 220. Once the total load is calculated, the main breaker should be sized to the next standard size that is equal to or greater than the calculated load. It is important to avoid oversizing the main breaker, as this can reduce the level of protection provided to the feeder conductors. Another important consideration is the type of main breaker used in a sub-panel. There are two main types of circuit breakers: thermal-magnetic and electronic trip. Thermal-magnetic circuit breakers are the most common type and are suitable for most applications. They use a combination of thermal and magnetic elements to detect overcurrents and trip the breaker. Electronic trip circuit breakers are more sophisticated and offer more advanced features, such as adjustable trip settings and ground fault protection. They are typically used in larger electrical systems where more precise control and protection are required. In addition to the main breaker, sub-panels also require proper grounding and bonding. Grounding is the process of connecting the electrical system to the earth to provide a path for fault current to flow back to the source. Bonding is the process of connecting all of the metal parts of the electrical system together to create a low impedance path for fault current. Proper grounding and bonding are essential for minimizing the risk of electrical shock and ensuring the proper operation of overcurrent protective devices. The NEC provides detailed requirements for grounding and bonding in Article 250. When installing a sub-panel, it is important to follow these requirements carefully to ensure a safe and reliable electrical system. Another important aspect of sub-panel installations is the proper identification and labeling of circuits. Each circuit breaker in the sub-panel should be clearly labeled to indicate the load that it serves. This will make it easier to identify and troubleshoot circuits in the future. The NEC requires that circuit breakers be labeled with a description of the load they serve, such as lighting living room or receptacles kitchen. It is also important to keep a circuit directory up to date and readily accessible. The circuit directory should list all of the circuits in the sub-panel and their corresponding loads. This will be helpful for troubleshooting and maintenance purposes. Furthermore, it is important to consider the location of the sub-panel when planning an electrical installation. The sub-panel should be located in a dry, accessible location that is protected from physical damage. It should not be installed in a damp or corrosive environment, as this can damage the electrical components and create a safety hazard. The sub-panel should also be located in a location that is easily accessible for maintenance and repairs. In addition to these considerations, it is important to follow all applicable codes and standards when installing a sub-panel. The NEC provides detailed requirements for electrical installations, and it is essential to comply with these requirements to ensure a safe and reliable electrical system. Local codes and regulations may also apply, so it is important to be aware of and comply with all applicable requirements. Finally, it is always advisable to consult with a qualified electrical professional when planning and installing a sub-panel. A qualified electrician can assess the specific circumstances of the installation and ensure that the sub-panel is installed in accordance with all applicable codes and standards. They can also provide valuable advice and guidance on the selection of appropriate equipment and materials. In summary, the installation of a sub-panel involves numerous considerations, including the size and type of main breaker, grounding and bonding, circuit identification and labeling, location, and compliance with applicable codes and standards. By carefully considering these factors and consulting with a qualified electrical professional, you can ensure that your sub-panel is installed safely and reliably. Remember, electrical safety is paramount, and it is always best to err on the side of caution when working with electrical systems.